तो अपने कुछ क्वेश्चन और देखने। द आउटर मोस्ट shell of an atom of an element is 3d 3, the spectral symbol 3d 3. So this is 3d 3 is 3 electron. So L is S is half half half, S equal to 3 by 2, and for D 2s plus 1 equal to 4. So here n equal to 3 and n equal to 2. So when you do it multiplicity, what the hell, give me 1 minute. Okay, now good. So S will be 3 by 2 and 2s plus will be 4. So 4 will be there, and then n equal to 3 and l equal to 2. So this is not the way we'll do it. This is the way we'll do it. So we'll simply put ml. ml is 210. So ml is 3 and it's equal to 3 by 2. So j minus a, l minus s to l plus s. So j will be this value, and the term symbol will be 2s plus 1 lj. 2s plus 1 is 4, l is f, then this. Now ground state is the lowest energy, less than half filled. So 4f 3 by 2 is the lowest. Now the term symbol for the electronic count state for the oxygen is, so oxygen is 1 is to 2 is to 2p4. So just do it for 2p4. What you will get? You are getting 1 is 0, 1d2, 3p0, 3p1 and 3p2, and 3p2 will be ground state because it is the more than half filled. So highest J will be there. Now which of the following is an allowed electric dipole transition? Allowed electric dipole. So for allowed electric dipole transition, delta S should be 0, delta L 0 plus minus, and delta G 0 plus minus 1, and parity must be changed. Here parity is not changing, S to S both are even. Here parity is changing, and J is 5 by 2 minus 3 by 2 1. J is allowed, and P to D delta L equal to 2 minus 1 equal to 1. Satisfied? So it is allowed. Is it allowed? 1 by 2 minus 5 by 2 4 by 2 delta J equal to 2, not allowed. Here 0 to 0 transition is not allowed, so only this is allowed. Now using Ohm's rule, the total angular momentum J for electronic ground state of nitrogen atoms. For nitrogen is 2p3. So 2p3 is 1 1 1 1 0 minus 1. L equal to summation of L0, S equal to 3 by 2, J equal to 3 by 2. So J is 3 by 2. Now there are 4 turns 3d. So 3d and 4 electron. And isolated term, the total magnetic moment in ball में total magnetic moment निकालना, वो निकाल लो, L निकाल लो, S निकाल लो, और यहाँ से J निकाल लो. और जब J निकाल लोगे तो अपने पास क्या आया टर्म 5d0. ग्राउंड स्टेट कौन सी? ये वाली. क्यों क्यों ही ग्राउंड स्टेट की? ग्राउंड स्टेट की कौन सी है? लेस देन हाफ फील्ड. सो म्यू जे इक्वल टू जी जे ई बाई 2m इंटू जे. सो जी ग्राउंड स्टेट के लिए क्या आएगा? लेस देन हाफ फील्ड, एस 5d0, म्यू जे इक्वल टू 0. Getting my point? This is the ground here, J is 0, put J equal to 0, mu J will be 0. Now which of the following transition is not allowed in the case of an atom according to the electric dipole radiation selection rule? So this is parity change, this is not parity change, so it will not allow. The number of spectrums resulting from the LS coupling of a 3p electron and 3d electron is, so 3s and 3p, so L1 and S1, L2 and S2, total and total S. So from LS coupling, what we'll do, we'll find out J. So 1 0, first we take 0 1 0 2 and 0 3. So there will be 3 terms simply for 1 1 and 1 2 and 1 3. J will be minus J2 plus J. So 3 3 3 3 3 6 3 9 3 3 6 9 10 11 and 12 terms. Total 12 terms will be there. Now positonium in an atom made up from an electron positron, given that the Bohr radius of the ground state of atom is, so ground state of is n square h square upon 4 pi square kd square, and ground state is 0.529 n square upon z, and the radius is proportional to m, r is proportional to mu. So what will do? Hydrogen atom and positonium ion will be inversely proportional to mu p and mu h, and mu p is me by 2 and here is mp, and we are considering nucleus mass of nucleus is mass of proton. So infinite heavy nucleus we compared is mu equal to me, and for positive reduced mass will be me by 2. Just put it here. The reduced mass of hydrogen atom is mp, and reduced mass of positive atom is me by 2. So it will be cancelled out. It will be 2 times of RH, which is 1.06 ms2. So the radius of positive atom is 1.06 times angstrom. Now a negative muon which has mass nearly 200 times of electron replaces electron in lithium ion. Now energy is minus 13.02 upon n square. So in this proportional to 1 by m, so it will be same as lithium. Now a proton of energy is k shell electron of a beryllium atom. L shell electron jumps to k shell. One L shell electron jumps to k shell to fill this vacancy and emits a photon of energy. Emits a photon of energy 109 from electron volt. In this process, if the ionization potential is 6, ionization potential from here to here is 6.4 electron volt, and photon of energy is 115.62. So this will be there. So total photon energy will be gone to ionization potential of K plus kinetic energy of electron, है ना. And the IPL, ionization potential of L कितना दिया अपने को 6.4 electron volt. So just IPK minus IPL be 109.2 electron volt. So IPK equal to IPL plus 109.k electron volt. IPK equals 6.4 109 115.6 electron volt. So kinetic energy will be HU minus IPK. So this will be 20 electron volt will be the answer. This question we have already done. Now we will go through our next part of the study, which is basically the Zeeman effect. So let's focus on the calculation of level splitting due to spin orbit interaction. So because of spin orbit interaction, energy levels are splitted out. So what will be the splitting? EH square upon 16 pi square m square, so J into J plus 1 minus L into L plus 1 minus S into S plus 1 by R, average of 1 by R dV by dr, and the average of 1 upon R cube equal to Z cube upon A naught cube N cube L plus 1 by 2 L plus 1, where L is greater than 0 and naught is Bohr radius. So delta ES will be equal to, in terms of energy, R infinite L phi square Z की power 4 SC 2 N cube L L plus 1 by 2 L plus 1 J plus 1 minus same, where R infinite is constant, L phi finite structure constant, L phi is E power E square upon 2 epsilon SC E square upon S cos C. This should be remember, L phi equal to 1 upon 137. So the splitting will be minus delta S by SC R infinite L phi is equal to N cube L by 2. For single optical electron alkyl atoms, S is half, L, J is. So when you solve it, you are getting plus L and minus L plus 1 in this condition, in this condition. So the effective delta T splitting will be cross L plus 1 for these conditions. Now this should be remembered to us. Okay, why? This is the original splitting in spectrum. So after solving we get 5.84 Z minus sigma raised to power 4 N cube L plus 1 centimeter inverse. Means whenever Z increases, delta T also increases. Whenever N increases, delta T decreases. And we replaces Z with J effective. Sigma is scaling constant. It will be negligible. So with N increase, delta T decrease. With delta T increase, Z decrease, delta T increases. And with L increase, delta T decreases. So splitting for S shell is 0 because L is 0. If the final structure splitting between the 2p3 by 2 2p 2p1 by 2 levels for hydrogen atom and 0.4 centimeter inverse, corresponding splitting in lithium plus 2 will be approximately. So delta T is this, and sigma for lighter nuclei we neglect sigma, so it is 5.8 per Z is power N cube by L plus 1. Here N equal to 1 given to us, and L equal to 0 for hydrogen dike structure lithium plus 2. So delta T is Z की power 4. So delta lithium by delta T of hydrogen is splitting 3 to the power 81 times of hydrogen. Now suppose this is same for hydrogen, So what will be the splitting in this condition? So we know that delta T is Z for n cube L upon L plus 1. So Z is 1 for hydrogen atom, both are same. Now for same atom it will be n cube L plus 1. So lithium and hydrogen, so n cube L plus 1. So for lithium is for this D is 2 and L plus 1, sorry n is 2, n is 2 for here hydrogen atom. Inverse proportional, so this will be for hydrogen, this will be for lithium. So 2 L plus 1, here also 3 and 2 plus 1, so it will be 0.039. Now Zeeman effect. Zeeman is a 1806 observed as light source giving spectrum in an external magnetic field. So Zeeman was scientist in 1806 observed a light source giving a spectrum in an external magnetic field. The central line emitted by the atoms of the source are splitted, very important, into a number of polarized components. So the effect of magnetic field in the spectrum is called Zeeman effect. Now there are certain points. A singular spectral line viewed at the right angle to the magnetic field direction is splitted in the three plane polarized components. So what will be this three plane polarization? First is central unshifted line. This is central unshifted line with electric vector parallel to B, which is called pi component, and then the two lines equally displaced in either side of E perpendicular to B is called sigma component. So central line is pi, then it is sigma, it is also sigma. This is called normal triplet, this pair is called normal Zeeman effect. So singlet state, external field is 0. Now when external field is not equal to 0, it will be split out in three component, sigma and pi. So pi is E parallel to B and sigma is E perpendicular to B, sigma is E perpendicular to B. The final structural component of multiple spectral lines however forms complex Zeeman pattern. Example, dividend into components of sodium yellow doublets. Give 4 and 6 lines respectively in Zeeman effect. This is known as anomalous Zeeman effect. Now normal Zeeman effect. Normal Zeeman effect, which is shown by all the lines due to transition between singlet state of atom, can be explained by quantum theory without taking the node of electron spins. So we are not considering electron spins, and mu L is defined as this. So GL is 1 for pure orbital momentum, LH is this, and lambda is being defined EB upon 2m. So delta equal to omega LZ, EH cross upon 2m MLB, and delta T equal to delta E by SC, very important. So EB by 2m, EBML by 2m, and H cross will be H upon 2 pi, H will be cancelled out for H, 4 pi MC. So delta T will be L1 ml, L1 is EB by 1, 4 pi MC, which is constant Lorentz units. So here you can see delta T splitting it directly proportional to ml, and we know that ml has 12 plus 1 values. So in normal Zeeman effect, a singlet level is pressed into 12 plus 1 levels. Got it? Okay, now selection rule is delta ml equal to 0 plus minus 1, and delta ml, how we calculate final minus initial. So let's take this answer 1t2 to 1p1. So this is 1p1, this is 1t2. Now since it is 2, so 2j plus 1, it will be split into 5 components, and this is 1, so it's split to 2j plus 1, it will be component 3 component. So this will be plus 1 0 minus 1, 2 1 0 minus 1 minus 2. Now let's take the transitions. So transition is delta ml equal to plus 1, this green, delta ml equal to 0, this 3, and delta ml equal to minus 1, this 3. Okay, you have to remember the selection rule. Okay, delta ml 0 plus minus 1. So total are 9 transitions, and lines in the spectrum will be 3 with respect to each ml. Now singlet is no splitting, first group 1d2 and 1p1. Triplet is second group d3, d2 and d1. So triplets are given singlet as well as triplet, second group. Now normal Zeeman have applied to transition between singlet state only. So normal Zeeman effect is applied for only singlet state. Now in normal Zeeman effect, contribution of spin angular momentum is not taken. Contribution of spin angular momentum is not taken. The normal Zeeman effect is occurs strong भी. कैसा चाहिए अपने को? Strong magnetic field चाहिए अपने को. Such that there is no time for spin coupling, LL and ZT coupling. Generally, orbital angular momentum is greater than spin angular momentum. There are always 3 spectral lines, which are 2 sigma and 1 pi. delta m equal to plus minus 1, delta m equal to 0 for this. Intensity of 2 sigma component equal to intensity of 1 pi components. In normal Zeeman effect, in singlet level splits into 2 electrons on different levels. So thank you very much. Rest will be tomorrow. Bye bye. Please